Mhm.
Exhibit A is Scrum, Exhibit B is safe.
Yeah.
Make things way more and the thing is,
We get hate mail every time you say that, or we say that. It's just like,
I don't know. Um,
it's fun though. It's fun. It's good hate.
Welcome to another edition of Drunk Agile. This is actually part two of Drunk Agile. We already did the first part of it, but we didn't record it. That was kind of on purpose, but
Like
kind of not.
halfway through, we were like, huh,
Maybe, maybe
Yeah,
we should
yeah.
hit record on this. So anyway, I'm Daniel Vacanti. With me, as always, is
Thing.
Pratik. What are you drinking?
Um, Too bright. Manzanilla cask matured, Benriach, Glenlivet, 15 years, 55.2%.
Cool.
Whiskey weather.
Yeah, I'm sticking with the Garrison Brothers because I think I mentioned on one of the previous shows. Um, my cupboard is bare. So
Are you
I've actually,
are you getting refills
I'm
soon?
hoping I sent my mule over there. So
Yeah, I
I'm
know.
hoping I get, there's no guarantee that I will, but I'm hoping it will. Anyway, tonight's topic is Monte Carlo simulation. So,
What?
yeah, weird. Uh, if, if, if you're one of these sad people that follows LinkedIn, you know that there's been a lot of discussion on LinkedIn lately about Monte Carlo simulation. We are not going to get into any of that, right? If you want to get into any of that, that's what LinkedIn is for. Here at Drunk Agile, we care about practical stuff, and hopefully advancing the state of the art. Although that second part could be debated. However, um, about what, 4 years ago, 5 years ago,
Yeah,
you did
something.
your
I don't remember exactly.
master's thesis in data science. So Pratik did a master's in data science. He wrote up this blog. I stole a bunch of this stuff, a bunch of his work, and threw it in my book. And the whole idea is, can you improve on a random sampling algorithm for Monte Carlo? Because the Monte Carlo simulation critique that we preach is admittedly fairly simplistic. You know, it's like just look at your historical throughput, randomly sample from that, and kind of predict the future. Can we introduce any sophistication into that algorithm to make our predictions any better? And that's where Pratik's research come in. So Pratik, take it away. I don't know how you want to talk about it or what do you want to say or
Yeah, let's take it kind of model by model. So first thing, that as Dan said, the usual model that we run is look at your past, randomly sample from the past and assign it to the next day. Then randomly sample from the past, assign it to the next the day, the following day, so on and so forth, and run that 10,000 times, get an answer. Um, that's a standard model that we use. Now, the questions that we were asking were, are there better models? Just randomly sampling, is that sophisticated enough to be giving us good answers? Could there be better alternatives, like, for example, one of them being, um, usually Mondays are slower, Fridays are slower. So in the middle of the week is when most of the work happens. So
and
can
hopefully
we
nothing
go
gets done on the weekends, right? Right.
fully? Yeah, so can we sample Mondays from Mondays, past Mondays? Can we sample Tuesdays from past Tuesdays? Saturdays from past Saturdays, so on and so forth. Like get the whole, like that could be a model we could set up and see how well does that perform. Um, we could make that a little more generic and go, what if we just sampled weekdays from weekdays and weekends from weekends? That will kind of get to the point that Dan was making. Hopefully things don't happen on Saturdays, but every once in a while there's a fire and someone has to put it out on the weekend. So that will get sampled. How often does that happen? Those are the kind of things we wanted to explore to see if we went with slightly more sophisticated models, does it give us better results? I'm not going to get into how we measured the results. But essentially what we were doing was backtesting. We were trying to figure out, we had data for 6 months. We were trying to figure out if we use data from the first month to project the next 5 days or 10 days, 14 days, whatever that is, uh, how accurate were we with these different models?
And just very quickly for reference, if anybody wants to read kind of a much more in-depth version of this, Pratik wrote a blog. Like I said, it's called "All Models Are Wrong, but Some Are Random." So you can Google that, or my third book, the Actionable Agile Metrics Volume 2, took that blog and kind of updated it and tweaked it for some. They're essentially the same. It's the same information. It's just kind of presented in a little bit more updated format. So you have those two options for you if you want to go read in much more detail what Pratik is talking about. So anyway, sorry, Pratik, go on.
Yeah, so those, so far, the models that I've described, the advanced models that I've described, are calendar based. We had other techniques that we tried as well. There was I don't even remember when I first heard about Monte Carlo, Markov chain Monte Carlo. It was from you, but I don't remember exactly what year it was. I remember sitting in a big office that we all shared. But
No,
yeah,
we were actually in Steve's office. We were
Steve's
actually,
office. Yeah,
yeah,
Steve's
yeah.
office. That where you and I sat for a couple of
Oh, right,
months.
right, right. Yeah, yeah, yeah,
Yeah.
yeah, yeah, yeah.
Um, but so the way, and this is gonna be a little geekier, for as if we could get geekier. Um, the way Markov chains work is they figure out the state you're in right now. What is the probability that you're going to stay in the same state, or what is the probability you're going to move to from state A to state B or state A to state C? And then when you're in the new state, we figure out what the probabilities from moving from that state to the previous state or a newer state. The way I first heard of this explained was, for example, if it rained today, there is a greater likelihood that it will rain tomorrow. So the current state that you are in kind of sort of determines what state you're going to get to. So we did that too. We did that with throughput, saying things like, if today was a zero, what is the likelihood that tomorrow will also be a zero throughput, or tomorrow will be five? We read in the data and kind of drew the state diagram that told us how likely we are to go from one state to another. That was one form of Markov chain Monte Carlo that we did. Another format was Markov chain by throughput range, which was say usually high throughput days are followed by low throughput days. Let's figure out how often that happens. If you got a really high throughput, how often do you go from high to low? How often do you go from low to medium, medium to low, high to high itself? Figure out all those probabilities, and every time you sample, you take those probabilities into account. So again, a much more sophisticated model than the pure random. And we ran all of these. There was a sixth one, which was essentially randomly picked from all these different models and use that for every simulation and figure out what a consensus ensemble tells us. A pure aggregate ensemble. What does it tell us? So those are all the models. Dan, anything to add to those model descriptions or any further thoughts on?
Yeah, not really. Other than to say, in each of those cases, we had a specific hypothesis. Not we, Pratik, had a specific hypothesis that he was testing. That this would make the model better. He kind of alluded to all
Right.
that, but he was like, hey, sampling from weekdays, sampling weekday data from a weekday in the simulation, that should be better, than just randomly picking something, you know. Um, knowing that we're on a zero right now, it probably
Mm-hmm.
gives us a better idea of what our next throughput should be versus just again random. So the reason that he came up with these six models was he had different hypotheses that he was trying to test out, in terms of does this come up with with a better prediction than just the pure random approach.
And I
Um,
mean, and again, you can read the details in the paper and everything, but I think I ended up running about 200 million simulations with these,
yeah.
with real team data
We
to
were just
kind of.
talking about that because you're using that laptop now, and it's like, hey, I wonder why this laptop doesn't work the way that I.
No, I was like, I need a new laptop. Oh, the drive on this must have like scratches on it.
Um, so I don't know. Should we just like long story short, should we kind of jump to the punchline, or
Yeah,
I mean,
in those simulations when we back tested and checked again, we used
oh,
real
we should
team
say
data.
that. Use real data. What was it,
Yeah,
60 some
we,
odd teams or 80 some
I
odd
think there were
teams
like
or
80 odd teams, and I don't know, 60 odd teams or 80 odd teams. I don't remember, but
I can look it
then
up.
80 odd predictions per team to kind of see which of these models perform the best. The results are interesting because the model that we in general have been using seem to perform the best. That random models seem to perform the best out of them all. Um, what we did was we ranked for each prediction for each team, which one gave the best predictions, which one gave the worst predictions, um, and the random models seem to perform the best
Yeah,
of all
in
of
the
them.
in the interest of full disclosure, particularly something called a prior score. We're
Yeah.
not here to maybe talk about the merits or the philosophy behind the prior score, but assuming we should maybe do one on Elo at some point too.
Right. Elo and Briar probably combine the two.
Yeah. Anyway, that's neither here nor
Because
there.
you should put two stories together
Yeah,
when
and
you
make make
can.
make them bigger. Yeah. And so that's how he was judging these, and for me that was kind of the astonishing takeaway was that a step up in sophistication of the model didn't necessarily
Yeah.
yield better predictions. Now we'll talk about the caveat to that here in just a second, but
Right. Well,
but in the vast majority of the case, in the vast majority of cases, what was it, 66% or 70%,
yeah,
the random performed the best,
better
and in
did
like
that.
close to 90% random was either first or second.
First or second. Yeah.
And so I mean it's like adding complexity to your model doesn't necessarily really buy you anything.
Mhm.
And which is great on so many levels because, if you've got a very, very simple algorithm, that means that, hopefully it can be applicable to a wider set of scenarios. It's obviously much easier to run. It's much easier to understand. It's much easier to everything, right? Which kind of in and of itself was a result. What were you going to say
Right.
something?
No, and you started talking about the caveats there. There are a couple of side results that we should talk about too.
Hmm. Hmm.
Um, for teams that were very inconsistent, um, I, I I did not have enough knowledge of process behavior charts at that point for me to say they were unstable, but at least they were inconsistent in throughput. Some of the more complicated models performed better. So the more inconsistent or seemingly unstable the system was, the more complicated models were better, which is an interesting result because that tells me that whenever you have to use a more complicated model, one of the first things you should look at is the data you're looking at, is it stable? Is it actually for a team that's doing things the right way?
Now the thing is that's probably a drunk agile episode all in and
In
of
itself.
itself
Yeah.
because so much of agile guidance and advice is trying to make things more complicated than they should be.
Mhm.
Exhibit A is Scrum, Exhibit B is safe.
Yeah.
Make things way, way more and the thing is,
We get hate mail every time you say that, or we say that. It's just like,
I don't um,
it's fun though. It's fun. It's good hate. Keep it coming.
and it's funny is because people think we need to make our models more complicated or our thinking more complicated, when in fact, what we really need to do is simplify the process, right? They're like,
Right.
well, but the model doesn't match the process. Right.
Yeah.
Correct. So don't change the model, change the process, right?
Right.
In most cases, right? In most
In most
cases.
cases, and I think that was a for me that was a very interesting result because we from gut feel had a feeling that some teams, and we knew from at least anecdotal evidence that certain teams, Monte Carlo did not a random Monte Carlo did not work very well for them because
Yeah.
for whatever reason, like they would pull the rabbit out of the hat in the last moment or whatever it was.
Well, like you were talking about before we record, we're talking about like if you have a team that is, 0 0 0 0 0 0 0 0 0 0 20,
Right.
0 0 0 0 0 0 0 0 0 17,
Yeah.
yeah, I mean, yeah, random and we would get complaints about that. We would get, I mean, you would get complaints all the time about that dashboard you built. Oh, the
Yeah.
dashboard's wrong.
Yeah. Well, yeah, but I shouldn't say
Again,
that.
these are
Again,
all other Drunk Agile episodes. Are you putting them up on the
yeah.
magic whiteboard, by the way? Because yeah.
Yeah. Yeah, definitely. And you get complaints about that, and it's from their perspective, from a team's perspective, it kind of makes sense. It's like, hey, we always do this. We do 0 0 0 17. That's what we do. That's why a more complex model like a Markov chain by throughput model that a lot better to say, oh, usually zeros are followed by this percentage of time. It just modeled that better for those teams. There were some hyperparameters that we had to change a little bit to make it work, but that's for another day.
Yeah. The,
The
oh, good. You good.
I was gonna, the other thing which we were talking about just before we hit record was also we and I got one of the usual early morning texts from Dan.
Actually, I think I hit you. It was probably like 5:30 or 6 o'clock
It was like
your time.
5:30 a.m.
Yeah.
that,
Yep. It's par for the course for me.
hey,
Yep.
did you try a hybrid model? And like, yeah, there were certain things that we kept this limited, right? This research was limited to these six models to kind of see how things work out. There are there are so many models out there on so many combinations out there that we haven't tried. There's a possibility. There's a possibility that there is a better model out there. We just don't know yet. We haven't proven that yet.
Well, the thing, if you and like I said, I highly recommend that you go read Pratik's blog, or probably even better, go read my book. But the thing that Pratik didn't touch on that really, when I started looking at this in a lot of detail, the three that I would have expected to perform the
Mhm.
best were the random, the simple Markov chain, not the Markov chain by range, and the weekends and weekdays, right? Those are the three algorithms that I would have expected to work the best. And what's interesting is the longer that you extend out the forecast range. So like if you're forecasting, what's going to happen in the next 5 days versus what's going to happen in the next 50 days, those are wildly different forecasts, right? And it would make sense that algorithms would behave differently based on that time frame. And what was interesting to me is as you extended out that time frame, regardless of some of these other variables that we were talking about,
Right.
those three models that I just mentioned, I thought would work the best, actually converged
Harder to
and
converge. Yeah.
and gave you the same results. So that was, to me, that's the other fascinating thing that suggests that there's something, underlying those three that make them perform better. I mean, I mean, I can make some hypotheses right now, but we would, we're not going to be like other agile coaches. We'll actually go test this, right? Um, but I
What?
believe, to your point, yeah, to your point, I believe that there's something there. I mean, there's obviously a
Yeah.
next iteration of this.
And again, there's the other side of this, right? Like, not to we also don't want to get into p hacking, right? So there's the
Yeah.
other side of this, which is when you're going further out, that cone has expanded so much that all of these are landing in the vicinity of the right answer. It's just
Well,
and
yeah.
so it's more of eliminating bad models at that point and saying, okay, these might be the right ones.
Right. Yeah, it's just yeah, that length of time showed a fairly distinct bifurcation, in the models.
Mhm.
That that's
Yeah,
that's if nothing else interesting, potentially suggestive, right? I mean, I guess
yeah.
that's all I'm trying to say. But um, so this has been a really really geeky episode. If
If you have stuck with us so far,
if you're still with us and you haven't been drinking, Congratulations. I just want to say
Kudos. You know.
thank you. But I think what this demonstrates is, you know, there is power in using methods that other industries, that
Mhm.
other contexts, that other whatever have embraced. This idea of, oh yeah, we can estimate complexity, or we can relatively size things, and that will just kind of take care of itself. I've got a lot of things to say about that. But at the very least, I think this proves that's misguided. That type of thinking is misguided.
Yeah, and there's the I mean, I should have more. There's a- there was serious research to be done, not just hand waving.
Yeah.
Uh, we prove these things out. I can at least say this for Dan and I. I'm sure there are others out there too. We prove these things out by one, applying them in real context and seeing results, and then going, oh, let's test this theory out in a broader context and see what it is, or vice versa. Have a theory, do the experiments in a theoretical space, and then try it out with in real context. Both of those things are the way we usually get to these conclusions, not writing things off just because we don't understand them. So.
I have to say, we'll figure out how to edit this episode later, but this, this
Yeah.
it's something that came up in another form, because what you're talking about, this gets back to our previous episode about science,
Mm-hmm. Mm-hmm.
science versus empiricism, science
Yeah.
versus just guessing or whatever, you know. There is a group of people out there that believe that science is, let's get a bunch of old white dudes together and all of them have an opinion, so let's compromise on everybody's opinion. We'll take a
Yeah.
little bit of yours and a little bit of yours and a little bit of yours, and that compromise is what's best for the industry. That's not how science works. I'm sorry. That is
Okay.
just not how science works, especially the old white dude part. Anyway, Pratik, I'll give you the last word since, or is there anything else to
Yeah.
say?
No, it was a fun.
Uh-oh.
I'm
She wants
being
whiskey
attacked.
too. Yeah.
Actually, was a skit being attacked. It was a fun having access to all that data and running all these different models was definitely a fun experiment to do. It was fun to prove these things out. Um, I I'm hoping we can develop more and more of these and figure out where the next horizon for this is, because so far I haven't found anything better than random.
Yeah.
So
And for me, that's bottom line, right?
yeah.
What we've been, so as of 2025 or whatever, what we've been teaching for the past however many years, um, seems to hold up under scrutiny. That's not
Yeah.
to say that there's nothing better, but it's probably good enough for most contexts.
And that is science. That is
Yeah.
science. You gotta continuously try to prove yourself wrong to say, hey, this is what I think, this is what I know right now. Maybe there's something better. I'm gonna go find it.
So that's it. Let us know what you think. Have you found anything better? Have you played around? Has anybody out there been playing around with different sampling algorithms for Monte Carlo? And have you come up with something that's both qualitative and quantitatively better than just a pure random approach? We'd love to hear from you. But in the meantime, thank you for your patience in sticking with us. This episode's way longer than it probably should have been. Maybe we'll figure out a way to edit this and break it up into multiple episodes. I don't know, or whatever. No matter what, just want to say thanks so much for joining. Thank you, Pratik, for the insight. Thanks to Suba for the cameo
Yeah.
appearance. And most of all, thanks to all of you for watching. We're glad you're here, and we will see you in the next episode. Bye, everyone.
It
If you like this content, all of you know how YouTube works. Please like and subscribe to this channel. We'd love to get your feedback and love to put more quality content out for you. Pratik, what else can they do?
Use the links in the description to reach out to us. You can find us on LinkedIn. See if there's a way we can work together. That'd be awesome.
Yeah, we'd love to see you. Thanks everybody for watching, and we hope to see you again very, very soon.